Hello everyone, welcome to CodeUp. Today let us solve the LeetCode's daily challenge, and the problem is number of islands. It is a frequently asked coding problem in every top product based companies, and given let us jump into the problem. Given an m cross n 2D binary grid matrix which represents a map of ones which is island, which is a land, and zeros which is water. Return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So this is the matrix that we are given. This is the input matrix that we are given. This one represents land and zero represents water. So an island is considered if a land is surrounded with only waters. So consider if we are taking this as a starting point, and the lands which are connected to this are these all ones, and even this one will be get connected, and these ones as well, and these ones as well. So if we see in this input matrix, there is number of island is 1. If we consider this matrix, the number of island is 3. Why so? Here this 4 forms an island, since this are surrounded with waters, and this one he himself forms an island because all the 4 directions it is connected with water, and these ones are also considered to be a separate island because it is all surrounded by waters in all 4 directions. In other 4 directions, it is out of the matrix. If we consider the valid positions, it is surrounded with waters. So this is what the problem is, and it is a standard interview problem. How can we approach? As we can see this grid, we can think of some. We can think of this as a graph problem because these ones are connected. If we want to say it an island, many lands should be connected. So this one is connected with this one, and the bottom one, and this one is connected with this one, and this one as well. So if we consider this input matrix, we can consider it as a graph. So to traverse a graph, we have two traversals, BFS or DFS. Here we are not required to we are not required to find any minimum steps or minimum time to format, so we can go for a DFS traversal. So what we are doing is, if we have a starting point, from that starting point, if we expand our graph using DFS traversal, it will visit all the connected cells, right? If we start the DFS from this point, this will visit all these ones and it will come back. And if there is a one here, if there is a separate one here, if this is going to be a starting point, it will visit this one alone. So likewise we can do a DFS traversal. So we have to find the starting point. So how we can find the starting point? We can just do a matrix traversal with 2 for loops, and if we see a 1 in the grid, then we can say just do a DFS traversal. And how many DFS traversal we are doing, that many number of islands are present. So finally we are going to return the count of those islands. So what we can do is, let me code the approach so that it will be more clear. How we are going to DFS traversal? We will just do a recursive function in all the 4 directions and visit all the cells. That's it. First we can take the m is nothing but grid dot size, and n is nothing but the grid column size, grid of 0 dot size. And now actually we have to run a for loop, we have to traverse the entire matrix. So int I equal to 0, I less than m, I plus plus, and another for nested for loop, in j equal to 0, j less than n, j plus plus. Okay, this is going to traverse our matrix. So we don't want to modify our input matrix. So what we can do is, we want to know whether the cell is visited or not. So for that we can have a visited array that is going to say whether this is visited or not. Visited of m size and n columns, and initially I will make everything to be 0. If my grid of ij is going to be a 1, and if this is not visited, if this is not visited only, I have to do the traversal, right? So do dfs, I will pass the grid, I will pass the visited array and j, I and j, and even I will pass, yes, I pass the row and columns, and we can have a variable which is going to store our answer, namely islands percent, which is 0 initially. Whenever we are doing a dfs traversal, that is where we find an island extra. So finally we are going to return this at the end of the day. We are going to return this island number of islands. Now we are, our ultimate aim is to write this dfs function. This dfs function is going to take the parameters vector of class, which is grid, and even this visited array. It should take visited matrix. To be more clear, it is going to take this visited matrix as well, and int I and int j. This is this current cell and the size as well. So okay, fine. What will be a base condition? If first we have to check whether this I and j is going, before doing this base conditions, we can just come inside this function. We have to visit this I and j. We should make this as true. After visiting this I and j, we have to go for all the 4 directions. To go 4 direction, we can do a simple technique. What we can do is, if we are at this current cell 0 comma 0, let us it will be more complex. If we are at current cell 1 comma 1, the upper cell will be nothing but 0 comma 1, and the left cell will be nothing but 1 comma 0, and the right cell is nothing but 1 comma 2. And the bottom cell is nothing but it is 2 comma 1. So what we are doing is actually, here the row is minus, here the column is minus, here the column is getting added with plus 1, and here the row is getting added with plus 1. So we can define a delta rows. I will have a static variable directions. I will name it as directions. We are having 4 directions with 2 coordinates, and here first the row is getting minus 1 comma 0. Next the row is getting plus 0 1 comma 0. Next the column is getting minus 0 comma minus 1, and the column is getting plus 0 comma 1. So here we have the directions array. So we have written the directions array. Now we have to go for all the direction. Int del equal to 0, del less than 4, del plus plus. Now we have to go and visit all the cells, grid and visited, and I is nothing but int del I, del x. Del x is nothing but I plus directions of del 0, and similarly in del y is nothing but j plus directions of del 1. And instead of passing I and j, we have to pass del x, del y, m and n. As simple as that. It will take all the 4 directions, all 4 directions. Now what we have to do is, we have to write the base conditions. What are the base conditions? We have to check whether the I and j is in valid position inside the matrix or not. So we can have a we can have a function which is going to check whether it is valid or not. It is going to return a bool function, bool type is valid int x, int y, and the rows and the columns we have to just return if my x is less than 0. If my x should be greater than or equal to 0, and x should be less than row, and my y should be greater than or equal to 0, and y should be less than my columns. If it is going to return me false, I'm just doing the not of that, and if it is true, then this is not a valid position. Or if my visited of ij is already visited, or my grid of ij is going to be a water, I don't want to visit it again, just return me, or else I'm just visiting. So this is what we are doing in this dfs function. It is quite a generic function, readable only. We are going in all possible 4 directions and we are visiting. That's it we are doing. Hope I made it clear. Let us try to run our code and see whether it is passing our test case. Yeah, it is getting passed, and let us see in for other examples as well. 1 minute. Okay, it is getting passed, and we have to check for another base condition with if my m is 0 and my n is also 0. If it is an empty grid, we can just return 0. This is a base case. We have to write it in case of interviews. Here, no, not necessary. Let us try to submit our code. Superb, it got accepted. And hope you like this video. Let me know in the comments. Let us see in tomorrow's LeetCode daily channel and solve them. Until then, bye.